Fischer projections is an important way of looking at molecules or viewing molecules or representing molecules in stereochemistry. In Fischer projections, all bonds around a specific tetrahedral center or carbon are shown as solid lines, so as if they are on the plane. All bonds, or four, if you like, different groups around a tetrahedral carbon are represented by solid lines. And of course, in order to draw or represent a specific molecule in Fischer projection, it would be very important to learn how to convert a tetrahedral drawing into a Fischer projection. And of course, in tetrahedral drawings, if you remember, two bonds are on the plane, two bonds are on the plane, and two bonds are outside the plane. And of course, two bonds on the plane, two bonds outside the plane, and it doesn't really matter how you look at it. This is on the plane, therefore this should be represented by a solid line. If you recall, this also should be represented by a solid line. This bone is outside the plane, it's towards you as a viewer, so it should be represented by a heavy wedge line. This bone is outside the plane, and therefore, or at the rear, therefore it should be represented by a dashed line or a dotted line. Okay, so something like that. Let's draw it, and then we see how we would convert it into a Fischer projection. So this model actually, it's like this drawing. So this blue bone on the plane, this yellow bone on the plane, the green one is outside the plane, it's at the back or at the rear. The red one is outside the plane, but it's towards you as a viewers. That's why it's shown or represented by a heavy wedged line. So the first step into the conversion of this tetrahedral drawing into a Fischer projection is to rotate the molecule. So again, this is the model, that's the structure, the way it's drawn. What we need to do is we need to rotate a little bit like this, so that these two bonds, which were outside the plane, they point towards you as a viewer. These two bonds, which were outside the plane, they now point towards you as a viewer. The two bonds which were outside, which were on the plane, are now actually behind. So what we need to do, therefore, is we represent the drawing like this. So again, we begin with this. We rotate the molecule so that we get something like that. So two bonds now point towards you as a viewer. Two bonds which were actually solid line point away from us or away from you as a viewer. Now, so this is basically the model. So the next step after this is to actually flatten it up, if you like. So if we flatten this up on the whiteboard, so what we get only solid lines. Only solid lines again. So this is blue, that's blue. This is yellow, so that's yellow. This is green at the back, and this is red at the front. So remember, these two bonds are on the plane. These two bonds are outside the plane. Red is outside the plane to the front. G or green is outside the plane to the rear or to the back. So from here, we rotate the model like this, and then we get these two bonds, which were outside the plane, now point towards us. So it's like they should be represented by heavy wedged lines. So G, therefore, here G, and of course red, that's R. And of course this one is B for blue, and this is yellow, Y for yellow. So again, we begin here, and then we rotate like that. So these two bonds point towards us as viewers, and the other bonds which were on the plane towards point at the back or at the rear. And then we flatten this up. It's like we flatten it up on the whiteboard, and then we get solid lines. Okay, remember these bonds are B for blue, and this is R, and this is G, and this is Y. So basically, the two bonds which were on the plane, they are now vertical. So B and Y are now vertical. This is very important. These two bonds which were outside the plane, G and R, they were outside the plane, they are now represented horizontally. All bonds are represented by solid lines. So these two bonds again, these two bonds become vertically or vertically drawing, vertical if you like. These two bonds, okay, should be represented by horizontal lines in the Fischer projection. So B and Y were on the plane. Now they are on a vertical line. Okay, they are drawn vertically. G and R, they were outside the plane, and now they are drawn horizontally. Let's take another example in order to practice this further. Now, this drawing, let's assume that that this is a model for it. So this is this. You see this red bond is on the plane, solid line. The blue one on the plane, solid line. So we can write R here for red, blue for B for blue. The red bond and the blue bond are on the plane. These two bonds are outside the plane. This outside which points towards you as a viewer. So this is G therefore. And this bond which is outside the plane but at the rear or at the back, it's yellow. So the yellow bone is outside the plane at the back. The green bone is outside the plane to the front. The red and the blue ones are on the plane. So what we need to do is we need to rotate the model like this slightly so that the yellow and the green now point towards you as a viewer. The red and the blue point away from you as a viewer. In other words, the two bones which were outside the plane, now they point towards you or towards the front, if you like. The bones which were on the plane now are at the rear, or they can be viewed as if they are at the rear, if you like. Okay, so from here, this is what we arrive at. So this is R, and this is B. The ones which were on the plane, they are now like at the back. These are the bones, or these two bones which were outside the plane. Now they are at the front. Let's again do this again. So red, blue, green, and yellow. So what we need to do is we rotate the model like this so that the yellow and the green now point towards you as a viewer. And these two bones, remember, are outside the plane. These two bones, which were on the plane, are now at the back, if you like, or at the rear. And there you go. These they are at the rear. Now, what the last step is to flatten this up, so that we can represent all bones using horizontal solid lines, vertical and horizontal, of course. So that's R, that's Y, this is G, and that's B. And again, it's clear, just like before, that the bones which were on the plane, R and B, now they are vertically drawn. R and B were on the plane, they are now vertically drawn. Y and G were outside the plane, and they are horizontally drawn. So again, if you want to repeat this again, so R on the plane up, B for blue, yellow, and G. So this is the original drawing or model. We rotate a little bit like that to achieve something like this. So this basically. B and R are behind. These two bones are actually behind, represented by dotted line. G, green, remember, G and yellow. That's G and yellow. They are at the front. So these two bones at the back, R and B, red and blue, green and yellow, at the front, and then we flatten this up just like what we did before, so that we get solid lines, and that's the Fischer projection of this tetrahedral drawing. The bottom line again, as we learned before, is that the bones which were on the plane, they become vertical in Fischer projection. Okay, the two bones which were outside the plane become horizontal. So R and B on the plane, again, R and B, they are vertically drawn. Y and G, they were outside the plane, they are horizontally drawn. So Fischer projection, therefore, is another way of viewing molecules. And in Fischer projection, all bones are represented by solid lines.